Hello students, welcome to Advanced Deep Learning. So today I will teach the first experiment. You can see the first experiment, that is object detection. So you take any image or any video stream, you have to identify the object. So let me execute the program first. So you go to Google Colab. Here is the Google Colab I have opened and the first experiment is here. Change the runtime mode. So change runtime type, GPU mode you change. I have already executed the program, and same program you can run in your laptop. So in the first cell we are importing PyTorch code, CV2 for computer vision code. To run this program you need to install this Ultralytics. So already I have done. Just you need to upload the file. So image 2 I have uploaded, just right click here and upload the file. So here is the file, I have uploaded this file, image 2. So once you run this code, you will get YOLO 5 model. So now here we are going to identify objects in the image using YOLO 5 model. See the next line we are taking the model is YOLO 5 model, already pre-trained model we are taking. That model is loaded and you can see the model here. For this model the input image is given. So here is the image is reading here and the details are shown. Now the model takes the image. Your YOLO 5 model takes the image and results are calculated and displayed down. You can see the result. So as per the image we have 4 objects: car, person, a laptop and dining table. So this image shows 4 objects and this anchor box. This box are called anchor box, and this is the confidence score. When you are identifying the object, the confidence score of each object is displayed, and down you can see this is the anchor box coordinate: x minimum, y minimum, x maximum, y maximum. That is from the origin, width and height. For example, for this object here is the origin and this is the width and this is the height. So this box, now you can see 4 objects are there, right? 0, 1, 2, 3. There are 4 objects: person, laptop, car and dining table. And the confidence score which is listed in the anchor box is here. So that is the value. Now let me explain how this YOLO 5 model is working. What is YOLO model? YOLO model is used for object detection. There are many versions of YOLO model. In our program we are using YOLO 5. Here only one pass, only one forward pass we are using, that's why it is called YOLO. You only look once. The idea of YOLO model is, when you give an image, it divides the image into grid. One single grid is taken to identify the object. So it tries to identify, and based on the maximum score it displays the object. So the general steps are, it dividing the image into grid, a bounding box is drawn, we have seen in the output, that is from the origin, width and height. Then object identification, then based on the probability which object is identified. Now we will see the inner detail. Suppose this is the image. Step 1 is, the image is divided into grid. Here this image is divided into 4 by 4 matrix. So 1, 2, 3, 4. Now each cell will be identified separately. Now let us take only one cell, this first cell. Inside this cell there is no object. So the identification is displayed in this vector. This vector is nothing but probability of class PC, then BXY, BWH, that is nothing but the anchor box XY coordinate, that is the beginning coordinate, and width and height. That is calculated based on the center value. Then class 1 and class 2, whether object is there or not. or person or dog, like that it identifies. So as per this first cell, so nothing is there, so this looks empty. Now you take the second example, that is this box. So in this box, based on this center point, the grid box will be drawn, correct? Now only this box will take, this second grid box will take, that is here. So it tries to identify the object, which object has more probability. Around 60% of this dog and some 30% of person head, right? So it identifies as dog. So this is, there is a object, means probability of the class, yes there is an object, and these four are the coordinates, this rectangle coordinates, and this is identifying dog. Same manner other grid. So like that any image if you give, that is divided into grid. So grid by grid this YOLO model takes and tries to identify the object. Now which model is used in our YOLO 5 model? So there are different versions of YOLO model we have, each model using different CNN model. Whereas in our lab program we are using YOLO 5, that YOLO 5 architecture is shown here. You can see 4 stages are here. The input is given, there is a backbone model and neck model, and that is prediction model. These boxes are predicting the final output. So step by step we will see all these things. So any input is given in this manner, maybe 416 into 416 or 640 into 640. So the backbone model, only this model will identify the features. If any images are given, what are the features are there? Here in YOLO 5 we are using this CSP darknet model. So different versions of YOLO model will use different architecture. Here we are using darknet for this. Then this neck model combines all the features. Then head model is predicting. So let me explain all the model one by one. So once image is given as an input, this backbone model will identify all the features, correct? Here feature extraction is done. Then neck model, larger object identifies, then medium objects, then smaller object. All objects are separately identified, then that is combined and given to the prediction. So in the prediction, based on the grid, all are identified, then compressed and given the answer. Here you can see from each grid cell, based on the identified object, anchor boxes will be drawn. Identification is done using sigmoid activation. More than one anchor box you may get, so the maximum confidence one will be used by using non-maximum suppression. So the final output has all this logic: bounding box, that is from the origin W and H, then which object, that class label, confidence score, you checked in the output. Now how backbone is working? Now in 3 models I told, 3 parts I told, that is backbone, neck and prediction model. Let us see how backbone is working. So backbone is only for feature extraction. The edges of, in the image, edges or patterns or any object parts, that is identified, and you can see the structure of backbone model. So if any image is given in this grid, there are CSP and SPP model here. So what CSP will do? You can see here 320 into 320, 64, again downsampling, 160, 160, again downsampled, downsampling, then same is maintained in SPP. So features are identified in various level: bigger object, smaller object, medium level objects, all features are identified. So you know how convolution layer will identify features. Then this SPP will take all this information, and all the multiscale context is compressed in this level. That output is given to neck model. Okay. When it comes to neck model, neck contains FPN and PAN. So the smaller objects details are done in one level, middle level objects features are done in one level, then the large objects are done in one level, right? Okay. So all this is done in neck level, that is compressed in pan, that is passed to the head. Now you can see the architecture. Here you see this small box is drawn because smaller object details are identified, medium level, that is the middle one, then bigger one. Any bigger objects are there in the image, that is identified. Now all these are combined, that is done in PAN. Now let us go to the deduction model. So here is an example how smaller object is done, middle level objects are done, then larger objects are done. So all are given to the prediction model. You see the example. Now here three different things are there. So this X train, Y train already we have seen. Images are divided into grid. Grid by grid vector values are given, trained in the model. So based on the training, object identification done. So here in this multi objects are there, right? Means a person and dog. We have two objects. When two objects are there, many anchor boxes are coming. So you can see the formula how the final maximum confidence one will be taken, right? That intersect area union divided by union area, that is intersection over union. So only this portion's maximum confidence is taken, that is retained and identified as object. Now you see the program. So here this anchor box identified with maximum confidence. So like that 4 objects are there. Here it's overlapping, but tries to identify the dining table, that is 0.26. That's all in this program. So practice this program. If you have any doubt, we'll discuss in the classroom. Thank you.